Hello, so today we're going to be talking about lateral flow tests in schools, the mass testing that's going to be happening in schools in the UK over the next few weeks, and why I think the statistics of it and the probability is interesting and why it's important. This is part of the guidance that was given to teachers on their handbook, and you can pause it and read all of it, or you can find it online. I'll link it in the description, but in particular let's focus on these 3 bullet points. Pupils and students will be offered 2 lateral flow device rapid tests spaced 3 to 5 days apart. The workforce will be offered 1 test in the final week and weekly thereafter as part of the longer term routine. And these lateral flow tests provided to schools and colleges are simple to use. They produce a result in under 30 minutes. So let's see why that is important. Let's start by looking at these flow devices and how good are they? So the sensitivity of a COVID test or any test is how likely are those tests to actually pick up a positive case. So you have a positive case, how likely is it to pick it up? Now, these facts are also in the government handbook, but I got them from the channel for fact checking about how reliable are these lateral flow tests. And there are basically 3 different groups they categorize it as: lab scientists, trained healthcare workers, and self-trained members of the community. And that is me, one of those self-trained, or what will be, I assume, a self-trained member of the community, because I'm a math teacher. And so this is why it's so important to me, because I am going to be living this. So for lab scientists, these tests are 79% sensitive, which means they pick up about 80%, 8 out of 10 positive cases. For a trained healthcare worker, the exact same test, 73%. But for a self-trained member of the community, only 60%, 58% to be precise, of tests actually pick up that positive case. So if we have 100 positive cases, each of these circles representing a positive case, the blue ones are the ones that are picked up by the test, and all those green ones, so that's 42 out of 100 of those dots, are not picked up by this lateral flow test. We also have been told that the specificity of the test was reportedly very, very high. We're going to assume for this whole thing it's basically 100%, which means you never get a false positive. If there is a positive test result, it is definitely a positive test result. So, in schools, let's look at what this might look like. We have Lucas here. Now, Lucas is showing up to school after the holidays and doesn't realise he has COVID-19. Most students are asymptomatic, but luckily his school is doing mass testing. What is the probability he gets a positive result? And see here, he has COVID, but what's the probability he actually gets that positive result? Now, it's going to be conducted by, we assume, a self-trained member of the community, maybe even me, although they're saying perhaps teachers won't be doing them, but still remember, 60% sensitivity, which means that when self-trained members of the community do these tests, they pick up 60% of all positive test results. And we're going to go with 60 for now, just to make the maths a bit easier. So, there are 2 options when Lucas has his lateral flow test. The first one is he gets a positive test result, which happens 6 out of 10 times, or 60% of the time. The other option is that he gets a negative test result, which happens 4 out of 10 of the time. Now remember, in both these situations, he has COVID. So what does that mean? Well, for 100 people with COVID, 60 of them will get a true positive, which means they have COVID and are correctly identified as having COVID, but 40 people will get a false negative. They have COVID, but they are given a negative test result. How bad is a false negative? In my opinion, a false negative is pretty horrendous. Because in particular, in a school environment, if you have students being told they are getting a test and they get a negative result, it seems pretty likely that they might be a bit more lax with the rules. Thinking that they are negative when they could be positive, that seems pretty dangerous. These 40% of all positive cases, not knowing that they have COVID, might lead to some lax behaviours. And in a school environment, is it even worse than testing? Well, I think probably not. We'll talk about that. But it is going to be very interesting dealing with a lot of students who have COVID, but get told they don't. What's going to happen to their behaviours? So, if one lateral flow test gives you a 60% sensitivity, what about 2 lateral flow tests? So instead of testing students once, how about we decide to test them twice? What do you think the new probability of correctly identifying a positive case is going to be? So what's the new sensitivity? Remember, for one test, it was 60%. What's it going to be for two tests? These are your options. Is it 60%, 120%, 92%, or 84%? So, pause the video. Make either... It's more interesting if you just make a gut assumption as opposed to actually doing the maths. So the answer is in fact 84%. We're going to see why in a second. I think, A, people might think, oh, these tests are independent. Every time it's just going to be 60%, so it's not going to matter. B, 120%. This is probably the most, maybe the most easy mistake to make. Because they're both 60%, well, if I add two 60s together, I get 120%. But as we know with probability, the max probability is 100% of something happening. So it's not going to be that. And 92 is just there to add a number that's a bit strange to see if people go for it. And the answer is 84. Let's see why. Well, two lateral flow tests. We still have Lucas with COVID, unfortunately. His first lateral flow test, either has a positive test, 6 out of 10, negative test, 4 out of 10. With the second test, we still have these two options, and they still have the same probabilities of happening, because every test is independent of each other. What you got on your last test is not going to affect what your next test says. So you still have 6 out of 10 for a positive test, and 4 out of 10 for a negative test. So at the end of each of these branches of this tree diagram, what will the probability be? So here we're going to be looking at the probability of two positive tests. And that will be this 60% and then the 60% again. But we actually multiply as we go across this tree diagram. So that's going to be 6/10 times 6/10, which is 36 out of 100, which is 36%. Okay, so there's a 36% chance that you get two positive tests in a row. And in this situation, it's good. He has COVID and he gets told he has COVID. Okay, the next one. One positive, one negative. Well, that's going to be 6/10 multiplied by the 4/10, which gives me 24%. But it's fine. Lucas has COVID and gets told he has COVID. Although, you might wonder how he would feel if he got a positive test and then a negative one. How much would he trust it? Even though the tests are very specific, if you get told you have COVID from these tests, you do have COVID. Pretty much all the time. Okay, next, one negative then one positive. Once again, 24%. And look, this is a good scenario as well. He has COVID and he's got told he has COVID. But the last scenario is the scary one. Two negative tests. So that's 4/10 chance of happening and then 4/10 again. So overall that's 16 out of 100, which is 16%. And in this situation, he has COVID, but he gets told he does not have COVID twice. In the first lateral flow test, there were 60% true positives and 40% false negatives. With two tests, there are 3 scenarios where you get told correctly you have COVID. In this case, positive positive, in positive negative, and in negative positive. And remember, if it test tells you have COVID, you do have COVID because it's that specific. There are very few false positives. So altogether, the probability of getting correct positive result is 36 plus 24 plus 24, which is 84%. You can also think about it as, well, the only way you could get negative negative is 16%. So if there's a 16% chance of two negatives, there's a 100% minus that 84% chance of getting a positive. So what does that mean for 100 people? Which I think is a great question to always ask with percentages. Well, we're getting now 84 true positives. 84 people that had COVID are correctly told they have COVID, and only 16 people, still a significant number, but 16 people get that double false negative. So if everyone does 2 tests, there are on average 16 people out of every 100 that still get told they're negative even if they aren't. And that's important to think about. 16 people out of every 100 that still get told they're negative even if they aren't. So, who and how often should we be retesting? So this is some information that is given on the government website. And the key thing is this. What if the test is negative? And all the government guidelines says, if it's negative, pupils will be able to carry on going to school and teachers will be able to carry on working. But with what we've seen, even if everyone does 2 tests, there are still 16 out of every 100 people that still get told they are both negative even if they aren't. And with 1 test, it's 40 people who have COVID. If it's out of 100 people with COVID, 40% of the people with COVID are told they don't have it. But the guidelines is just carry on going to school. This is so important. This is also from the government handbook on this for schools. This has to be used in combination with other measures: personal protective equipment, washing hands regularly, social distancing. These tests reduce the risk of transmission, but you cannot relax any of these measures. This testing program is in addition to them, and that is so important. Look, this testing is better than no testing. Even with one lateral flow test, picking up 60% of those cases is better than picking up none of them. You have to test, you have to know there are cases there. We need to talk about those false negatives, because remember, it's so important that this is used with other measures, and if you get a negative, it does not mean you are clear. Another idea is also that we only need to retest the negative tests. This is just more a slight change to the tree diagram. If you get a positive test result here, you do not need to do another lateral flow test. And actually what the government says to do is you should do a PCR test and then isolate based on that result as well, because they are more sensitive than these lateral flow tests. But in this situation, it's still the same thing. You have 84% where you get told correctly you have COVID, and still 16% where you don't. It's just you do not need to give someone another lateral flow test if they got a positive result. If they got a positive result, they have COVID. So what if I get a negative test result? Remember, for 100 people with COVID, I'm going to be saying this a lot, there are still 40% of people who have COVID but are given a negative test result. These falsely got told they don't have it, but they do have COVID. So it is so important people continue to follow guidelines, in particular, in between test results. So if you're doing 2 tests within 3 days and you get the first one negative, it's so important that you continue to do all the things to keep people safe. You should keep acting as if you have COVID to keep other people safe. So the key takeaways are, following guidelines is so important, even, not especially, but even with a negative test result, because remember, even with 2 lateral flow tests, 16 people out of every 100 still got told they're negative, even if they aren't. And in the first scenario, 40 people out of every 100 still have COVID, even though they got told they weren't, because of these lateral flow tests. Also, 2 tests, definitely better than 1, and definitely better than none. So 1 test, better than no test, because it's important that we know who has COVID. 2 tests, even better than 1. Going from a 60% to an 84% sensitivity, definitely an improvement. Although it is interesting to think about a situation where we have finite resources, or amount of tests where it's important to just test as many people as possible. We're going to see that as a bonus thought at the end. So, what's the government saying? Well, we saw them say this at the beginning. Pupils and students offered 2 lateral flow tests spaced 3 to 5 days apart. So interesting to think about what happens if you get that negative result on day 1. What do you do in those 3 days? You keep as safe as possible. Other thing to say that's very interesting, pupils, students and staff will be tested if they come into contact with a positive case. This new approach, known as serial contact testing, will allow those who are in close contact with someone who has tested positive for COVID-19 to return to school or college if they agree to be tested for 7 days. And the STAR, you can find the information in the handbook. I'll link it in the description below. And I particularly think that's a bit dodgy because, as we've seen, in particular, if you've been around someone with a positive case, chances are you might have got it. And a negative test does not mean, negative lateral flow test does not mean you do not have it. An interesting quote also from the template letter. So this is a letter that the government has put together for schools to send out to parents. And it says, "We know these tests work. In validation studies conducted by Oxford University and Public Health England, they were shown to be as accurate in identifying a case as a PCR test." So I'll just let you take that in, because I think the wording here is a bit tricky, because we've just seen that the sensitivity is absolutely not 99.68%. If you have COVID, it does not tell you have COVID with as much sensitivity as a PCR test. They are as specific, which means they won't give you false positives, but they will not tell you you have them, you have it when you do, as often as the PCR test. And look, they even say these tests have lower sensitivity, but are better at picking up cases when a person has high viral load, hence the need to test frequently. Look, testing frequently is very important. We've just seen that the odds go up, and you can continue. The more tests you do, the more chance you have of getting those positive results. But it's also something to think about, are the students that we're testing in schools, will they have high viral load? If they're asymptomatic, maybe not. So final thoughts. If a child or anyone gets a negative test result and does come back to school with their workplace work, if they did a lateral flow test, they could be one of the 40% of positive cases that are missed. So even if you have a negative test result, please, please, please follow the guidelines. That is the way to keep everyone safe. And additionally, if you have a close contact of someone in school test positive, remember that in between your tests, if you test negative, it could be a false negative. So make sure you're making decisions to keep yourself safe. And finally, what the government says, once again, this should be used alongside other things. Now we're going to finish with some bonus thoughts, which is just an idea about what happens if we only have a finite amount of tests. What should we do with them? So who should we be using our tests on? So if we only have 100 tests, and we have 100 students, and in this case, 50% have COVID, what are our options? Well, these are those 100 kids. Half of them don't have COVID in yellow. Half of them do have COVID in blue. What two options could we do? Well, one option, test all of them at once. Test all of them. So use all our 100 tests, test all of them. What would happen? Well, those 30 people would, out of the 50 people that have COVID, would be correctly identified as having COVID, because it's 60% of those 50 kids. 20 people will be told they don't have COVID when they actually do, because they're in the 50 that do have it, but the test is only 60% sensitive, so they get told they don't have it. So, no false positives, that's what we're assuming here, because they said the specificity is very high. We end up catching 30 positive cases. That's great, much better than testing none of them. But remember, 20 people out of the 70 people that got negative test results do still have COVID. So hands, face, space, super important. Another scenario, what if we only tested half of them, but twice? Would that be a better way to do it? Now remember, with 2 tests, we have 84% sensitivity as opposed to 60%. So what would happen? Well, we'd have 21 people correctly identified as having COVID, 84% of the 50 kids, and only 4 people now with false negatives. 4 people told they don't have COVID when they actually do. Now, this is interesting. We used the same amount of tests, but we've only caught 21 positive tests as opposed to 30, so we've caught less tests. There were less students that falsely got negative results, but remember, there are now 50 other students we just haven't tested, so they don't know anything about them, so they're going to assume they're negative. So in this scenario, even if with a finite resources, it does seem to make more sense to just test everyone with that one test, because the information we get is more useful than testing half the people twice. So, thank you very much for listening. I hope you have found this interesting. The main takeaway is, remember, 2 tests, better than 1 test, better than no tests, but because of the false negative rate, it's super important that you still abide by all guidelines as much as possible. Keep each other safe, protect the NHS, save lives. Thank you very much.